Hello everyone. In the last section, we learnt about the concept of null and alternate hypothesis. In this section, we will learn about two common errors in hypothesis testing, Type 1 and Type 2. Type 1 error. In statistics, a Type 1 error happens when you get false positive results. You conclude that the drug intervention improved symptoms when it actually didn't. These improvements could have arisen from other random factors or measurement errors. In other words, Type 1 error means rejecting the null hypothesis when it's actually true. It means concluding that results are statistically significant, when in reality, they came about purely by chance or because of unrelated factors. The risk of committing this error is the significance level you choose, also denoted by alpha. That's a value that you set at the beginning of your study to assess the statistical probability of obtaining your results. The significance level is usually set at 0.05 or 5%. This means that your results only have a 5% chance of occurring, or less, if the null hypothesis is actually true. If the p-value of your test is lower than the significance level, it means your results are statistically significant and consistent with the alternative hypothesis. If your p-value is higher than the significance level, then your results are considered statistically non-significant. The null hypothesis distribution curve below shows the probabilities of obtaining all possible results if the study were repeated with new samples and the null hypothesis were true in the population. At the tail end, the shaded area represents alpha. It's also called the critical region in statistics. If your results fall in the critical region of this curve, they are considered statistically significant and the null hypothesis is rejected. However, this is a false positive conclusion because the null hypothesis is actually true in this case. Type 2 errors. A Type 2 error means not rejecting the null hypothesis when it's actually false. This is not quite the same as accepting the null hypothesis, because hypothesis testing can only tell you whether to reject the null hypothesis. Instead, a Type 2 error means failing to conclude there was an effect, when there actually was. In reality, your study may not have had enough statistical power to detect an effect of a certain size. Power is the extent to which the test can correctly detect a real effect when there is one. A power level of 80% or higher is usually considered acceptable. The risk of a Type 2 error is inversely related to the statistical power of a study. The higher the statistical power, the lower the probability of making a Type 2 error. The alternative hypothesis distribution curve below shows the probabilities of obtaining all possible results if the study were repeated with new samples and the alternative hypothesis were true in the population. The Type 2 error rate is beta, represented by the shaded area on the left side. The remaining area under the curve represents statistical power, which is 1 minus beta. Increasing the statistical power of your test directly decreases the risk of making a Type 2 error. Trade-off between Type 1 and Type 2 errors. The Type 1 and Type 2 error rates influence each other. That's because the significance level, the Type 1 error rate, affects statistical power, which is inversely related to the Type 2 error rate. This means there's an important trade-off between Type 1 and Type 2 errors. Setting a lower significance level decreases a Type 1 error risk, but increases a Type 2 error risk. Increasing the power of a test decreases a Type 2 error risk, but increases a Type 1 error risk. This trade-off is visualized in the graph below. It shows two curves. The null hypothesis distribution shows all possible results you'd obtain if the null hypothesis is true. The correct conclusion for any point on this distribution means not rejecting the null hypothesis. The alternative hypothesis distribution shows all possible results you'd obtain if the alternative hypothesis is true. The correct conclusion for any point on this distribution means rejecting the null hypothesis. Type 1 and Type 2 errors occur where these two distributions overlap. The blue shaded area represents alpha, the Type 1 error rate, and the green shaded area represents beta, the Type 2 error rate. In this section, you learnt about the very important concept of statistics, i.e. the Type 1 and Type 2 errors. In the next section, you will learn another important concept of statistics, confidence interval and standard error.